Greetings, we are Team Kanbananis. In this video, we will be displaying our sheet press project on how our prototype worked. Within our mechanical integration and design course, our group was designated to create plastic sheets out of shredded plastic pellets to help address the plastic pollution issue Earth faces. Now the team had objectives to meet, one of which was creating a sheet that was 1 foot squared with no holes, less than 20 minutes for heating for the whole process, approximately 1 minute or less for cooling, and the prototype would have to be compatible with a variety of plastics including PET, ABS, HDPE, PP, and PVC, plus having a repeatability with intolerance for each sheet being created. The team was also faced with some constraints, including a $200 budget, a project time of 148 hours, power of 120 VAC, 15 amp breaker max, and a targeted 10 amp for the whole prototype. In addition, we had plastic temperature range only from 120 to 180 and a desktop size weighing less than 30 pounds for portability. Now that you got some background on the project, let's see it work. First step to our process was turning on our modified camping stove. This stove was controlled by a PID controller and a solid state. And while the team waited for preheat to be done on the steel plate, the second component to our prototype were the pre-molded aluminum sheets. The main manufacturing process used in our prototype was compression molding. In preparation, the bottom plate was coated with a thin layer of baby powder as a mold release agent. Then a weighed amount of plastic was placed into the bottom plate of the mold. Finally, the top plate was placed on the aligning with the guide screws so the top plate can move up and down freely during the pressing process. Once the preheat on the steel plate reached a range between 140 to 160 degrees Celsius, the filled mold was placed on the steel plate and positioned for bracing so the molded sheets could get an even load distribution. Once the molded plates were in position, the actuator was turned on and extended at the top of the mold until it began stalling when it could no longer compress, and then switched to neutral. The first side of the molds remained like this for 10 minutes. Once the 10 minutes were up, the actuator was then retracted, braces were removed, and the mold was flipped and repositioned again for the backside of the mold to then be compressed and heated. Once the 10 minutes were up, the actuator retracted, the top braces were removed to our cooling rack, and the mold was carried outside for a dose of cold water until it was safe to touch the mold. The remaining steps of the process include using a screwdriver to pry open the mold, releasing the plastic sheet, and cutting off any plastic flash which seep outside of the mold. The sheet shown in this video was made out of PP and had an average thickness of 1.6 millimeters.